Today's webinar is on three-dimensional visualization in a web browser. And why do you want to do visualization in a web browser? Well, there are a number of reasons. Perhaps you want a portable platform. You want anybody in the world with a web browser to load your visualization and explore whatever data set you want to show them. You can publish your own data set, let's say scientific data set from a numerical model on the web, and anybody with a web browser can just go to a website and browse your model and exploit it in 3D. Perhaps you just want a simpler platform. If you are using three-dimensional desktop visualization tools such as ParaView or Visit or a few others, you know they are incredibly powerful, incredibly rich, but they have lots and lots of menu items, and it can be quite intimidating for novice users at the beginning. So if you want to have a much simpler, much cleaner interface, you can actually program your own visualization, your own website with one of the tools I'm going to talk about today. And it's going to have just a few controls that are needed specifically to do what you want to do. And finally, if you want to have a mobile or touch-friendly interface, then using one of the tools I'm going to show you today is actually a really good way to go, because you can load your visualization on a mobile phone, on an iPad, and just interact with it, play with it using the touch interface. So on the other hand, if what you want to do is visualize a local data set that you have on your laptop or on your workstation, it does not really make much sense to use web visualization, simply because if you're using a native tool like Visit or ParaView or VMD or maybe something else, you will have a lot more power. So if you have a local data set that is not too big and you can fit it into memory on your own workstation, then you probably want to use things like ParaView or Visit. You don't need to do a web visualization. So if you're computing on a high-performance computing cluster and you have a large data set that you want to visualize, in that case, using web visualization is also probably not the best option. In that case, you want to use something like a native desktop client on your laptop, and then a remote server perhaps running in parallel on compute nodes on that cluster. So you have a client on your laptop, a remote server on the big machine, and then you organize a link SSH connection between the two, and then you will have to, that way you can actually perform very large-scale three-dimensional interactive visualization on your laptop. Well, you have full impression that you're doing this on a laptop, whereas all heavy lifting will be done by the remote server. So rendering and data processing are going to be done by the remote server. And this is really the preferred way to deal with large data sets. So again, here you don't need to do web visualization. Today, I'm going to show you lots of examples, and in all these examples, I'm going to use the following mathematical function. So just a function of in 3D. It's called assign envelope wave function, and I use it regularly in teaching. And the reason I do that is because it just has this nice shape with branches, and it just looks very nice. So it's a very simple mathematical function that you can easily discretize on a Cartesian mesh in 3D and then load it into a visualization program. And if you want to generate this data set yourself, here is the Python code to do that. So in this Python code, I load NumPy. You need the NumPy package, and then you also need the PyEVTK package. And if you Google it, you will find the instructions how to install PyEVTK. So the reason I'm using PyEVTK is because I'm saving this three-dimensional NumPy array as a VTI or VTK file. So it's a 3D function discretized on a 30-cube Cartesian mesh. So today I'm going to talk about the following open source projects. These are commercially supported open source projects from Kitware, ParaViewWeb, VTK.js, and then ParaView Glance. 3 years ago, in March 2017, I actually gave a webinar on ParaViewWeb. ParaViewWeb is a JavaScript library that you can use to build your own website. And this is a client, so you'll build your own client-side website that can optionally connect to a remote ParaView server. And that way, you can actually do pretty powerful visualization in a web browser, and all heavy lifting, rendering, and data processing will be done by the remote server. VTK.js is a JavaScript library. And so similar to ParaViewWeb, if you want to program in VTK.js, you have to know JavaScript, obviously, and I find that there's actually quite a steep learning curve. So I don't program in JavaScript normally myself, and actually preparing for this webinar, I had to refresh my memory of JavaScript, and there is quite a steep learning curve. But once again, once you start programming in VTK.js, especially in VTK.js, It's actually quite a lot of fun. And then ParaView Glance is a web app, so there's no programming at all. You just load a web app, and into this web app, you load a visualization, a three-dimensional scene, and then you can view this scene in the web browser, or you can send a link to this scene to anybody else in the world. Let's begin with ParaViewWeb. ParaViewWeb is a lightweight JavaScript API for writing client-side HTML5 web applications, as I mentioned, to display three-dimensional scientific visualization in the web browser that can optionally, so this web page can optionally talk to a remote ParaView server. And essentially what you do with ParaViewWeb, it's an API, it's a library, and you use it to build a web page. And there are a number of pre-built web pages or pre-built web applications available. And the most complete app is Visualizer. It's open source. Visualizer itself is an app in ParaViewWeb JavaScript that is open source. And it's hosted in its own GitHub repository. But if you Google it, you'll find it very easily. Actually, there's a link on this slide. It relies for, as I said, for heavy rendering. It relies on a remote ParaView server. And then for anything small scale, you can actually do visualization locally in your web browser by WebGL. So WebGL is a web implementation of OpenGL computer graphics library that will utilize your laptop's GPU for faster rendering. These are the applications that are available, or open source applications that are available in ParaViewWeb. And a Visualizer is the most complete of these. So a Visualizer tries to give you the full experience of ParaView desktop application in a web browser. And this is actually an example of what you can do with ParaViewWeb in principle. If you spend a lot of time, if you know JavaScript, then you can actually build a very rich application. Lightviz is a much simpler example with much simpler interface. And then Arctic Viewer is a standalone JavaScript viewer, so it's a standalone web page. There is no backend server for visualizing Cinema or Catalyst type pre-generated images. So the idea is that if you're doing scientific visualization that takes a lot of time to render, then you can actually use a special format to pre-render a lot of images and save these images in special Cinema, let's say Cinema database format. And then you can actually view these pre-rendered images in the Arctic View HTML5 web page. I'm getting background from somebody. Could you please mute yourself? Somebody who just joined in. Thank you. The visualizer, you can download it separately. So there is on the previous slide, there is a link to the source code, and you can install it in Node.js JavaScript runtime environment. And Visualizer is actually included into any pre-built ParaView binary. So whether you are on a Mac, on Linux, or on Windows, when you download the ParaView binary, you already have the Visualizer app installed. And this is how you run it on a Mac. It's shown on this slide. So in the ParaView binary, there are two things included. One of them is a special Python ParaViewWeb launch app that will launch the ParaView server and will build and launch the HTML5 application that will connect to the ParaView server. So it's a single Python script that will do everything for you. And I'm just going to show you a demo in a second. And then there's also the static HTML5 content directory with a visualized JavaScript code inside. So here's an example on a Mac, but there are instructions on the website here in the middle of the slide. There's a link to instructions for Linux and Windows as well. So in a Mac, for example, what I need to do, I cd into my ParaView application into the contents folder, and then I use this ParaViewWeb Python script, pvw-visualizer.py, to start the ParaView server and to open the HTML5 web page. So I need to pass the content directory with --content flag, and also I need to pass the data directory in which I have the data sets that I want to load into my instance of ParaViewWeb. And then optionally I can specify the port I'm running this on. So let's actually do this. I'm going to do this on my laptop locally, and I'm going to show you a local demo. So if I type start1 on my laptop, I have a script that just runs all the stuff that I just showed you. And let me just wait. Okay, I think it has started. And then what I need to do is I just open localhost. Okay, it's actually open on a different, let me see, localhost port 8080. And it is, let me close this guy. And here we go. So here it started the ParaView application. And if I want to load the data set, I click on this button. And in the directory that I supply to the script, there are three files. So I'm going to open signEnvelope.vti, the one that I mentioned before, the signEnvelope function. And here I have controls, so the three mouse controls that you typically see in ParaView. The left mouse button will spin the data set. The scroll wheel will let you zoom and unzoom, and then the right mouse button will let you pan in the plane of the screen. So the controls here are actually very similar to what you typically see in ParaView. Here I have my data set, and let me switch to a different view. So from outline, default outline, I'm going to switch to surface view. And it's actually going to be a little bit slower because I'm running the video desktop application, this video conferencing, in addition to the ParaView and this website. So it's going to be a little bit slow, but please bear with me. And then I'm going to color it by the value of the scalar field. So here we go. Very similar to regular ParaView desktop application. If you want to have a filter, you click on the plus button, and there are a number of filters. So let me do the contour filter, and I'm going to draw a contour at the value of scalar, and let's say 0.15. I hit enter, and then actually apply, you need to click on this button. So this is the apply button right here, the mail, I don't know, looks like a mail icon to me. And here we go. So now it's been applied, but now we have both data sets, the original data set and the output of the filter visible in the pipeline browser. So I'm going to hide the original one, and here we have the output of the contour filter. If I want to apply a second filter, I click on the sign envelope, and then I click on plus again, and let's do a clip filter. So here's a clip filter. Then it was applied. So here I have, I'm currently looking at the output of two filters, a clip filter and a contour filter. And here's my original data set. So let me make it visible, and then I will make the original data set semi-transparent. So I think it's probably in view. Let me just see where I have opacity. Maybe it's under representation. I can actually modify the opacity. Oh, right here. So here's opacity, and let's say it's 0.3. And then I need to hit this apply button. Oh, actually, I modified the opacity of the clip filter, and I wanted to modify the opacity of the original data set. So let me find it again. So I click on the original data set, and then here it is, my opacity, and then let's do 0.3, and then click apply. And here we go. So as you can see, the controls are very similar, and the functionality is very similar to the desktop ParaView application. Okay. Are there any questions at this point? If you have a question, you can type your question in the chat window, or you can unmute yourself. So this is the Visualizer app written in ParaViewWeb JavaScript. And in this case, it's talking to my local ParaView server running on this laptop as well. Okay, so there are no questions. Let me close this. Actually, I won't close it. Let me go here and then quit the script, and then I'll go back to the slides. This slide shows you a little bit more information. You can actually load more complex files, not just VTK or VTI files. You can also load netcdf files as well, and this slide shows you that you have to do a little bit more work in order to be able to support netcdf inside of ParaViewWeb. There's a question, hello, do I have to install ParaView on local machine? You don't have to install it now, but if you want to run Visualizer later on, if you want to play with it on your own time after the webinar, you will have to install ParaView, yes, on your local machine. But today you don't have to, I mean, for the webinar, you don't have to install anything. So I'm gonna show you some interactive demos, hands-on demos. You will do some visualization, and those things later on in this presentation you will do in your web browser. Okay, so writing ParaView web applications is a little bit, there's a steep learning curve, as I mentioned. It's JavaScript, and documentation is there, so there are a lot of examples, but I find that if you've never programmed in JavaScript, like myself, I don't really know JavaScript, then I find that it's really kind of a black box. There is a very steep learning curve, but if you want to put your time into this, you can, and you can actually run web applications similar to what you just saw with the visualizer. And if, as I said at the very beginning, if your goal is just remote scientific visualization, you don't really need to use ParaViewWeb because you can use client-server or batch off-screen visualization. If your goal is to share three-dimensional models online, again, you don't have to use ParaViewWeb. There are much simpler approaches. So there's ParaView Glance that I'm going to talk later on in this webinar. There are also, various 3D sharing platforms, things like Sketchfab. There's also an application called 3D Hop. It's a framework that essentially is a website skeleton you can download, and then it tells you there's beautiful, really good documentation in 3D Hop, and it tells you exactly how you can put a three-dimensional model. Typically, it's a polygonal model online on your web server. So if you're still interested in ParaViewWeb and if you want to develop your own application, let me know. If you are from WestGrid or from Compute Canada, so essentially from any Canadian research university or institution, I will help you. And you can all, no matter where you are, you can always email contact Kitware, the company who developed ParaViewWeb. And because they provide support for paid support, they'll be happy to write applications for you if you pay them. Okay, so the second part is more interesting. This is more fun. This is VTK, Visualization Toolkit. VTK, many of you, I'm sure, know about this library, stands for Visualization Toolkit Library. So it's been around for almost 30 years. The development started in the very early 1990s, and it's an open source multi-platform library for computer graphics, for image processing, volume rendering, and scientific visualization. And really, a lot of applications that do scientific visualization nowadays, things like VMD, ParaView, Visit, many others, they're all based on VTK because VTK provides all that underlying functionality and the application provides the nice GUI. So VTK was written in C++, and in the past 20+ years, it was ported to other languages, Tcl, Python, and Java. So Python is probably of most interest to the vast majority of attendees today. And it sits on top of a graphics library, typically OpenGL. So OpenGL you can run on a graphics card on your laptop. You can also run OpenGL functions entirely in software. That way, you actually don't need a graphics card to run VTK, because on a compute cluster, for example, the vast majority of compute nodes on a cluster don't have a GPU card. And it's also VTK is also parallel. So VTK itself, the native VTK code was parallelized for distributed memory architectures using MPI, message passing interface. And there's actually a separate rewrite of VTK called vtkM that was specifically coded for many core and GPU architectures with hundreds and thousands of threads. But it's a separate code base. So today I'm going to talk about VTK.js. And VTK.js is just implementation of the VTK library for JavaScript. And it does not implement all VTK classes, so it implements only a subset of VTK functionality. But even the stuff that you can find in VTK.js is really, really powerful. So there are a number of ways you can use VTK.js. If you're building a web app and if you're familiar with the browser development tools and with JavaScript, then typically what you do, you have a Node.js runtime environment and the web, what is called the WebKit, or I forgot. Anyway, so you have this JavaScript development environment installed on your laptop, and then you use it to compile to build a web application. So typically you program in JavaScript, ES6 code, and that way you can actually program fairly powerful web applications. And then if you just want to play with VTK.js, you don't need to have Node.js installed locally. You can simply build a simple web page, and you would import the JavaScript source via the script tag right at the beginning of the HTML page, and then the page will have your JavaScript source. I'm going to show you a lot of examples in the next 10-15 minutes. So the JavaScript code is imported from a global content delivery network, such as unpackage.com, and then you have this nice compact site which you can simply open, an HTML5 web page, you can simply open in your web browser and you'll get very nice visualization. So VTK.js uses WebGL for compatibility, and that means that your browser has to support WebGL in order to show this, well, in order to open this website. And really, WebGL 2 is recommended for best performance. So not all browsers support WebGL 2. Chrome, Firefox do. Safari, Internet Explorer, others don't. So make sure you can actually go to this website shown on this slide and check for WebGL 2 support in your web browser. So VTK.js is quite rich, even though it does not include everything that you can find in VTK. It still gives you the ability to build very, very complex and very feature-rich websites. So the main resource for VTK.js is the Kitware GitHub IO page. And they have a lot of examples there, so dozens and dozens of examples under both examples and API. If you click on the API tab, it will basically give you show you the list of all VTK classes that were implemented in VTK.js. And if you click on a particular class, it will give you more information and some examples. And documentation, you can also click on documentation. So I find that, again, not being familiar with JavaScript and ES6 and Node.js, I find documentation is kind of concise. So it's more of, here's what you can do, but then if you want to modify it, you really have to jump into JavaScript and understand the browser development tools. So this page is probably the most important one for VTK, well, for this part of the talk, for VTK.js. Because it shows you the data flow in VTK. And this applies both to the VTK in C++ and VTK.js. So without understanding what's going on here, you won't be able to understand the slides, well, the example slides I'm going to show you in a few minutes. So in VTK, you read data typically from a file. You have a reader that imports data from source, or perhaps you have a function in VTK that builds a very simple mathematical, very simple VTK object like a sphere, a cone, a cylinder, etc. So, but basically, you have a source or a reader, and then that data can optionally go to a filter or to a series of filters. There's a question. This current code is using memory RAM from the local machine or any remote server. I'm not sure which code you're referring to. If you're talking about ParaView, you probably were talking about ParaViewWeb, that was 6 minutes ago. Then that code was using a little bit of memory on the local machine. It was running inside the browser on your local machine. And then it was using memory on the machine that was running the ParaView server. So in this case, I was running ParaView server right on my laptop, so it was using the local memory. But if you connect to ParaView server not on your laptop, but on a remote cluster, then it will use a lot of memory on that remote cluster, so in that way it's very efficient. But it really depends how you start ParaViewWeb. Okay, so just to answer a previous question. And now going back to VTK.js data flow. So you have data from a reader or from a source, and then you can optionally pass it to a filter or to a series of filters. But here you still have, after a filter, you have your data object, the output of the filter, that you want to plot. And in VTK, this data object, you cannot plot directly. You have to pass it to a mapper. So a mapper takes your three-dimensional object and converts it into some well-defined geometry, like a series of lines, a series of points, polygons, etc. So that's what a mapper does. That's what a mapper does. And then the mapper outputs this data and passes it to the renderer. And the renderer has what is called a VTK actor. So the idea is that the mapper passes its output to a VTK actor that is part of a renderer. So a VTK actor is an OpenGL object that is inside, that is embedded into the renderer. And a renderer can have many VTK actors. So for simple visualization, you have just a single actor. But for more complex visualization, where you have multiple objects, you will have multiple actors. All of these actors take their data from their respective mappers, and then they are embedded into the renderer. So a renderer can have multiple actors, and then a renderer window can have multiple renderers. Okay. So, and the way you pass information between these different objects is done through these VTK.js, in this case, this VTK.js code functions. So a mapper gets its input from the output, from a given port in the output of an object. An object could be a reader, could be a filter, could be a source. And then an actor. An actor takes its input, so you set mapper for the actor, and you specify which mapper is taking its data from. And then the renderer, to the renderer, you add an actor, and you specify which actor is contained in this renderer. So let me show you the example. This is actually the entire website. I'm going to load it into my web browser in a few minutes, but let's just walk through the individual lines. The HTML page is called cone.html. It's entirely standalone, except that at the very beginning, it loads the JavaScript library from unpackaged.com. And then here I create a basic cone object. So I have a new instance of cone from the VTK library. I set a couple of properties, its radius to 0.3, its resolution to 50. So resolution of a cone is basically the number of points at the base of the cone. Then I map polygonal data into renderable geometry. I create a mapper, essentially. So a new instance of a mapper, and then I have to tell VTK where this mapper is taking its data from. So it's taking its data from cone, output port. There is a single output port in cone. So the data from cone goes into the mapper. And then I create a VTK, an OpenGL object, an actor. I call it cone actor. A new instance of it, and then this actor takes its data from the mapper, so the geometry from the mapper, and then I can optionally specify, so here get property, set edge visibility. Basically, I make the edges visible in the visualization. You will see it in a second. And this is similar. So setting this property edge visibility is similar to, it's one of the properties for the cone object if you're running ParaView desktop application. One of the properties of cone will be, render edges, or it's somewhere there, either in the properties of cone or in one of the view properties or render properties. Then I create a renderer, a full screen renderer. So here's my renderer, and then I create a render window. I add the actor to this renderer, so renderer add actor, the cone actor, reset the camera, and then I render my object. So let me load this page into cone.html into my web browser. I go here, and I'll just say open cone.html, and here we go. Here's the result. So I created the object, I created the mapper, I created the actor, and then the renderer, and I organized the communication between all these objects, and here's my result. And as you can see, the resolution of the cone is 50, so there are 50 points at the bottom, at the base of this cone. And then you can also see the edges because we turn them on by the properties of the actor. Okay. So let me go back to the slides. The next example here, all I do is just add a second object. So in addition to rendering a cone, I render a sphere. So here what I'm showing is not the full source code, but I'm running the div command. Those of you familiar with the Unix div know that when I pass two file names to it, will just show the difference between the first file and the second file. So greater than symbol means I include something, and then less than symbol means I take something out of the original file. So I add the following lines: the sphere object. Modify its properties, radius, theta, and phi resolution, and the center. So it'll be slightly offset from the cylinder. And I create a mapper for the sphere. So now in my code, I have two mappers, a cone mapper and a sphere mapper. And then I organize communication between the sphere object and the mapper. So data from output from the sphere object goes into the mapper. I create so here I create a sphere actor that takes the data from the sphere mapper, and then in addition to rendering the cone actor, I render the sphere actor as well. And the only line that I take out, I just delete the line where I turn on the edges, right? So you won't see the edges now. Okay, let me load this file into my web browser. Open conesphere.html. And here it is. So now I actually have the cone and the sphere is just sitting right on top of the cone. Right? Just a couple of objects. So essentially here I have two pipelines, one pipeline for the sphere where information flows from top to bottom, and then the second pipeline for the cone where information flows from top to bottom. Okay, let me close this page, and then I'll go back to the slides. The next example is more complex. This is actually really fun. It shows you how powerful VTK.js or VTK is. So here we'll add the glyphs. I'm going back to my original cone without a sphere. So I have my original cone. And then to each point on the cone, I'm going to add a glyph. So a glyph is basically a small marker. In this case, it's going to be a spherical glyph that I will put on top of each point inside the cone. So here I create a new instance of the glyph source. Then for each glyph, I set its radius and its theta and phi resolution. So it's going to be a nice high resolution sphere. And then I set the mapper for the glyph, and the mapper for the glyph is different. It's very special very different from the previous two mappers for the sphere and the cone, because it takes two inputs. Instead of taking just one input from the object, it takes two inputs. So there are two ports. One is the input from the cone. It takes the output from the cone goes into port 0 of the glyph mapper, and then the output of the glyph goes into the input of on port 1 of the glyph mapper. So there are two connections here. And then I set up the glyph actor. The information I set the mapper for this actor, and then for the renderer, to the renderer I add the glyph actor. Okay, so let me load this. Oops. Open glyphs.html. Oop. And now, yeah, this is kind of annoying because it opened in a different browser on a different screen. So here we go. So here we have a cone, and then we have a bunch of spheres. Glyphs are placed on top of each data point in the cone. Let me go to the next slide. And of course, you really want to use VTK.js for rendering of data sets, not just for displaying, these very simple objects. And there are quite a lot of renderers. So this is a partial list of, a lot of readers in VTK.js. This is a partial list of readers. I'm going to show you examples with the PDB reader for molecules and also an XML.ImageDataReader. So in VTK.js, you have to remember that because of security, it's not VTK.js is not a the web application. The website that you write in VTK.js, it's not going to be a standalone application in the sense that you cannot just load any file from your file system onto this website. There are security reasons why you have to follow a certain model. So if you are building a web app in VTK.js inside Node.js runtime environment, then that way you can actually copy a data file into your destination folder. Then you will build the web application, and then the data file will be available to your web application. So once your web application is built, or perhaps if you're just running a very simple example of a standalone HTML5 web page with VTK.js, then you have only two options to load data. One is you can load data from a public URL, and the second one is you can have a drop area. You can code a drop area on your website where you can take a file from the GUI from your file manager on your laptop, and then you can drag that file, and that way it will load it into the currently running HTML5 VTK.js website. Okay. So here is a more complex example, and in this example, because I have a lot of code, this is the full JavaScript application, but then there are also, this is not the entire website. So to actually put this in a website, what you need to do is take one of the previous examples, like cone.html, then take out all the JavaScript code from that, and then put this JavaScript into this website. So this is a website that displays the transport protein molecule that I copied from a VMD tutorial. I'm not sure which protein it is exactly, but it's basically a molecule that has hundreds and hundreds of atoms, so that it displays very nicely. And then here we have a reader, as you can see. So we create a new instance of the reader. Then we apply a filter. So the filter takes data from the reader. And then we can, in this filter, we can hide. So we use this filter to optionally hide some elements. In this case, I'm hiding oxygen, but there are a few other things I can hide. And then I set a mapper. And then data from the filter goes into the mapper. And as you can see, there are actually two inputs. Oh no, sorry, there is yeah, there are two inputs, and the reason for this is because the filter outputs both. It outputs two streams of data. It outputs the spheres for the atoms themselves, and the links, the connections between atoms in a molecule. So that's why you have the sphere mapper and a stick mapper. Then you create two objects, so two actors, the sphere actor and then the stick actor for the connections. And then you create the full screen renderer, you create the render window, and then to this renderer you add the spheres and the sticks. And then nothing is displayed yet because the way this is done with vtkJS is you have to make sure that you load the data. And so here I'm porting the reader to a URL, an external URL. In this case, I just took this PDB file and I copied it into somewhere on GitHub where I can just load it from, through a web browser. And then once this reading is successful, then I reset the camera, and then I render my PDB molecule. So let me go here and simply type open pdb.html. And here we go. So here we have our nice molecule. Right? And let me uncomment the line that hides the oxygen atoms. So if I go to here and I open the same HTML website, and then where I have the filter to hide the atoms, I'll just hide this. So save, yes. And let me go to the website and then reload the web page. And now in red, you can see I have all these oxygen atoms that I just, I commented out of the line that hides these oxygen atoms. The other example I'm going to show you with reading data is this. So the XML image data reader is probably one of the most important readers in vtkJS because it lets you read VTK files. So modern VTK files, basically they are underneath, they are an XML file, right? So let me show you. If I do in this directory, I have a file, let's say this guy, and this is essentially an XML file. So it's a VTK file. VTI stands for VTK image data. So that's essentially a three-dimensional Cartesian mesh with some data on top of it. And this file has the header, and the header is basically a series of XML tags describing the dataset, and then you have data in binary, right? So that's why this XML reader can read VTK files. So here's also the entire JavaScript code that you can paste into one of the previous HTML examples. And so here what I'm doing is I'm creating the renderer. I'm setting up a new instance of the reader, the mapper and the actor, and I'm organizing connections between them. And then I set up a transfer function so here's my data set. It's a three-dimensional volume based on the sign envelope mathematical function. But now I save this volume as an integer data set. And there the data roughly goes from 0 to 2000. So I want to have two filters where I highlight points around the value of 100 and points around the value of 1500. And they will be highlighted in blue and green. And then I set the opacity transfer function, and then basically some other properties for the lights, for shading, and then I load my data here, and if load is successful, then I add volume or set the camera, and eventually I render my data set. Let me open this. So I'm going to say open xml.html, and here we go. So now it's the same sign envelope function that I was showing before, and it's rendered in vtkJS, standalone HTML page. And as you can see, I have two, where's my side? I have two peaks, essentially two peaks in the transfer function at 100 and 1500, and that gives me blue and green colors. And this is what I see in my visualization. So there is green and there is blue. I find that the vtkXML image data reader is actually quite finicky, and I had to play quite a lot over this. So I had to spend, I don't know, half a day to make sure that before this example worked. And so just to walk you through the steps. So if you try to do it yourself, so you can actually see why it doesn't work. So no matter how I tried, I could not make it work with single precision or double precision floating data. I actually had to rewrite my code to generate the sign envelope function on the Cartesian mesh as 16-bit integer. And then, so that's why the data range there is from 0 to 2, so I multiplied by 1,000. And then the data range is from 0 to 2,000. Then I loaded this file into ParaView, and it turns out that that VTI file, after step 2, I could actually not load it into XML.html For some reason, it was just giving error messages. And then I loaded this file into ParaView, a VTI file into ParaView. I saved it as binary VTI file. It was binary before, but now it's just somewhat, I don't know, some different, slightly different binary format. And that didn't work as well. And then I had to edit the XML header in the final file to match the precise format of one of the examples from VTK.js tutorials, and only then it worked. And I have no idea why. So you have to have a very specific binary format, and you have to have a very specific XML tag format, and then it will work. Just to show you that if you try this later using one of your own data sets. Scene Explorer is kind of fun. Because so I'm not going to show you here the source code. The source, if you click on the example in the it opens again on a different screen. It gives you the source code right here, but this is source code that you will not be able to run in a standalone HTML website. You can port it, you can modify it so that it loads in a standalone HTML website. But here you can see that I have a lot of import statements, and basically this is for the ES6, Node.js runtime environment. So here you can use this code for building a web app. And what it does, it provides you this, it's a live example, it provides you this drop area into which you can drop files. So let me actually, I forgot what I wanted to drop. Oh, sign envelope.vtkJS. I will drop that. So this format, sign envelope.vtkJS, it's a file that I created in ParaView. So any visualization in ParaView, you can export, go to File, Export Scene, and then you export the scene as a VTK.js file. And then when you drop this file onto this drop zone, this is what you get, right? So this is a sign envelope function that is actually branded very nicely with a couple of filters: the cliff filter, and then the contour filter. Okay. So I think because we're running out of time and I want to show you some hands-on examples, I will skip the next few slides and we'll jump to ParaView Glance. So ParaView Glance is fun because it's very easy to use and there's no programming involved at all. So the way you do this, ParaView Glance is essentially a web application that was coded in JavaScript and VTK.js. And into this application, you can drop any scene, VTK.js scene. So in order to create a VTK.js scene, once again, you open your any dataset in ParaView, and you save this. Once you're happy with your visualization, you go to File, Export Scene, and then you save that scene as a VTK.js file to your laptop, and then you can take that file and drag it, drop it onto the website. So let me show you. Let me open this website. So here it is hosted by Kitware folks. Let's see, where is it? I have lots of browser windows. And of course, it opened on a different screen because I'm also trying at the same time to mute everybody when there is some background noise, and that's why I had a separate browser window on a different screen, but then it just tries to open all new tabs on the screen. So let me move it here. Sorry about that. I'm going to close this guy, and then I'm going to close this guy. So here is the ParaView Glance web application, and then onto this web application, I can actually drop a VTK.js file. I'll confirm. I'll say load, and then here's my visualization. And here you have a lot of controls that are actually quite similar to ParaView desktop application controls, but they are simpler. So here I have basically a bunch of objects. I have a clip, a contour, and then I have the clip and the contour, not the original data set. And then I can play with this. I can hide one of these. I can switch to different color map. I can switch to different representation. For example, for the clip, let's switch from a surface representation to a wireframe representation, okay, and so on. So lots and lots of things, and it's really fun to play with this. What I want to show you is that you can actually automatically load a visualization into the ParaView Glance, and all you need to do is use this special query syntax where you're passing the two variables, name and URL, to your ParaView Glance web application. And basically all you do is construct a ParaView Glance, construct this complex link, and I shorten it to what you see on your screen. So you actually, right now, if you open a web browser and into this web browser you type this first shortened link, it will give you the visualization right inside your web browser. We'll wait, I don't know, 20 seconds to make sure that you copy this to your web browser. And actually, let me paste this to the into the chat window as well. Not sure if it's, yeah, I pasted it into the chat window as well. And then let me click on this, and this will open the website, and it will load the visualization automatically. So here we go, and you can play with it on your own screen. So here I'm also running. I also implemented this ParaView Glance. I implemented a simple web server with a ParaView Glance application on a virtual machine inside our Abutus cloud in WestGrid. And it's the same application as in the first link, same website, but it's just to make sure that if the first website goes down, then I have this backup. And the point here, it's really very easy to compile your own ParaView Glance application and put it onto the website. And then, of course, you have these very long URLs, and they're really ugly, but you can actually pass them with JavaScript. I'm going to show you an example in a couple of slides. So the next example I'm going to show you is how you can automatically load multiple files into ParaView Glance. If you click on one of these links or type this address into your web browser, it will open a couple of files. So it will open two files. One is signenvelope.vtk.js, the previous example, and then second clip vtk.js will give you another clip on top of this visualization. So here we go. This is what it gives you. So now I shall see you have three objects. You have the output of the first clip, the counter, and the output of the second clip. And here I'm actually playing with the output of the second clip, right? Making it visible and invisible. And let me actually switch to different color map. Here we go. Here is an example, some example JavaScript code that shows you how you can pass very long URLs. So here, this embedded JavaScript code is solely to pass very long strings. But it's nice because you can have these variables inside of JavaScript that you set to a ParaView Glance application. So it could be the official ParaView Glance application, or it could be your own instance, or it could be a local copy of ParaView Glance running on a machine at localhost at some port. Then you set the data directory, then you set the file, and then essentially you have this long string that you're passing into the HTML page, right? And then you can have because here I'm using iframes. Here you can add additional stuff to your website. 3D sign envelope function before the visualization, and then it says more stuff in here after visualization, and it will give you a nice website. So the website is this entire web page is called embed.html. Let me open it right here, embed.html. And it will open a new instance where you see I have an iframe with an instance of ParaView Glance and the data set preloaded automatically, right? So you can actually see that right before I have 3D sign envelope function, and right after I have more stuff in here. So the point here, you can actually take this ParaView Glance application along with the data set and embed it right into your website. Another example is, let me go back to the slides. Another example is you can have multiple frames, right? So you just do it twice. There will be one data set on the left, one data set on the right. And if I open it, so website is double.html. It opens two iframes, one instance on the left, one instance on the right. they're not connected to each other. They will be looking at totally different data sets. So here we go. And then if you want to bring the ParaView Glance menu, you just click on this menu icon right here, and it will open the menu. Okay. Finally, let me show you an example. Here's how you build ParaView Glance on your own machine. But you can if you go to the ParaView Glance GitHub page, you will find all these instructions there. Essentially, what you need to do is install the Node.js environment along with npm, and then you check out a specific version. Well, you check out ParaView Glance source code from GitHub, and then here actually, when I was playing this a few days ago, the most recent version did not work for me. It broke, so the latest 4.9.4 didn't work. So I loaded a slightly earlier version, 4.9.0, and that works just fine. And then I type npm install inside of the Glance directory, and that will install all the various JavaScript dependencies into this Node modules subdirectory. Then you build it, and then you run the development website serving this web application, and here it is. So when you run this and when you open a local host application on port 9999, it will run a web server with and will serve the ParaView Glance web page. And then optionally, you can preload any data set into this. And actually, let me show. So what I'm going to do is I'm going to type start2, and that will go through the steps I just described, and it will start a local web server. Because it's running a local host, you will not be able to load it on your side, but I'm going to show you a couple of examples. So let's just, right now it's building the website, and it's starting the web server. It will take some time, maybe 20-30 seconds. And then let me click. So this is localhost port 9999. Let me open this. And most likely it will just say you have to wait. Yeah, wait until bundle finished. So let's just wait maybe 20 seconds. And by the way, this is the same mechanism, the same the commands I ran on the virtual machine on Abutus to make ParaView Glance available there. Okay, so just wondering. No, it's taking a little bit longer because I'm also running this video conferencing. So okay, so I think maybe it's done, almost. There's a question, what are the errors showing there? The errors are just so there are errors in ParaView Glance. The errors are just due to the fact that it did not like the range with the data range. And I didn't spend any time on this, but you can easily get rid of those errors. It's just data formatting. Okay, so here we go. Here it's serving ParaView Glance on my laptop, localhost port 9999, and then in here I can actually drop any VTK.js file, for example, the assign envelope, and here we go. And the last thing I'm going to show you is an actual scientific application. So a few months ago, I was working on a visualization, helping a researcher in Atlantic Canada at Dalhousie University. And there I created a vtkJS file. Just want to show you what I'm going to do is let me reload this page, and I will show you an example of a real scientific visualization. So that's that was a numerical model, oceanography model of currents in the Bay of Fundy here in the Atlantic Canada. So what I'm going to do is let me show this slide for this right here, real scientific visualization, and I'm going to click on this guy. Oops. Yes, it's loading the data set, and it'll just take a few seconds. Here we go. And all I do here is just preload a vtkJS file that I created a few months ago. And this is an actual scientific visualization. Here you have the Bay of Fundy, and you have topography, and I mean here is the ocean model, right? So you see the currents in the water, and this is just a single single snapshot. So unfortunately, right now, ParaView Glance does not support time-dependent data sets. It supports only single snapshots, but still kind of nice because, in order to render this single frame, it takes something like, I can't remember exactly, but it takes 20, 30 seconds to render it. You pre-render it and save the scene as a VTK.js file, and then you can visualize it nicely on any web browser without any dedicated visualization software. So what I'm going to do now is I will show you the last slide. Summary. I showed you three frameworks, so three projects. ParaViewWeb JavaScript library, which is a library for building HTML5 website, talking to a remote ParaView server. And you really want to use ParaViewWeb if you have a very large data set where you really need some remote processing to visualize that in web browser. But if your data set is not very large, then vtkJS is really nice alternative. And vtkJS is really fun to play with, but because it's JavaScript and it's VTK, if you've never coded in VTK, there is a learning curve. And then finally, ParaView Glance is perhaps the easiest of all of these because, well, there's no programming involved. You just start a ParaView Glance application, or you can even use, one of the ParaView Glance applications hosted by somebody else, and then you drop your data set on this application, and then you get a nice visualization in the web browser. Well, if there are no questions, thank you, everybody, and I hope this was useful. And we will see you in 2 weeks. So in 2 weeks, we're going to have a webinar on machine learning.